So we're in week 3. And what we're going to do is we are going to spend this week. The content is about filtering, which I know we talked a little bit about last week, where we have a where clause, and that where clause will, filter out our result sets. Basically, what the where clause does is it filters what rows appear in our result set. So the select list lets us choose what columns. The where clause lets us filter out the actual data itself, like which records. And just kind of flip through this reading, because the other thing we're going to do tonight is we're going to spend a lot of time talking about the final options, and we're going to go in depth. And I'm going to give you a rough timeline of how I would approach the final, show you all the deliverables, so that way you can kind of get started on them, kind of know what's expected. So that way you can make a good decision about whether you want to do the written final, or I guess the quiz final, or the project final. So we'll get to that in a minute. But we'll flip through the PowerPoint here real quick. We're just going to do it real fast, because this honestly is something that a lot of this is stuff that we've all seen before. So anyways, we're going to go through some of these, and you can kind of see a broad overview. We talk about equality comparison operators, which is, equal to, is last name equal to Smith? Yes or no? Is last name not equal to Smith? Is our non-equality? Then we have a range where we say, is the date paid between January 1st and April 2nd? So range comparisons. We will kind of deeper dive into subqueries and wildcards. And then null values can sometimes be a little tricky. So we want to make sure we handle null values appropriately, which can be a little confusing, but it's not too bad once you kind of think about it. All right, so the where clause, basically we have, we can stack multiple clauses on top of each other in the where clause, or multiple conditions rather. So let me hurry and open up Workbench, because I want to show this, because most of the time in examples, we'll see a lot of, where this is equal to that, and stuff like that. But a lot of times we never see things really combined, like many kind of views combined. So let's use Sequila. And let's say we want to select everything from customer, and kind of see our data here. So there we go. There's some data. And let's say we want to base this on, well, let's see if there's a different one. Let's see what film has to offer us here. So I know it has a rating, I think. It has language and rating. Okay, yeah, so this has a little bit more data we can use to filter on. That'll make somewhat sense. So what we're going to do is we're going to just select everything to keep things simple from film. So this is our where clause, and we can kind of add multiple conditions together. So I like to think about it as the where clause can handle one-to-many conditions. So we can kind of add them and kind of layer these filters on to kind of match whatever logic we are trying to build. So for example, if we want to say, let's say we only want it where the release year was equal to 2006, where release year is equal to 2006. Cool. Now, let's say we also want to filter down to say, and the rental rate is 99 cents. 0.99. So we can run this, and now we get kind of a smaller list. So at this point, and however you choose to format it, I like to kind of stack them. But as we'll get further along, just to kind of make it easier, the way this is kind of working is it has to both be 2006 and the rental rate is equal to 99 cents. So I'm just going to delete this so we can kind of get back here. Now, let's say we want to add, this is where we're going to kind of get a little confusing. So let's say we want to say that the rating can either be G or PG. So at this point, we could say, and because we want this to be an additional thing. So this is kind of where, at least for me, when I was learning, it got a little weird. So I really like the use of parentheses because, as we all know from math, it helps break us down order of operations. So what I like to do is say and, because we want this to be an additional filter. And this is where we can say rating is equal to PG. Now that would exclude all of the G-rated films. So we add an or inside of the parenthesis to say rating is either PG or it's G. Now, if we were to run this, we should in our list see both PG and G movies. Now, if I were to, because this is where some people get confused, if I were to say or here instead of and, now what it's doing is it's actually checking to see if either rental rate is 99 cents or it's PG or G, which can get a little confusing. Instead of, you'll notice how we get these because it's either 99 cents or it's PG or G. So we're going to get all the different rental rates for PG and G, and we're going to get all the different ratings for 99 cents. So it's important that you think about it when you do your and or. Like I said, I like to use kind of math with parentheses and block them up that way. Does that make sense to everybody? Anyone want me to pause there and go over that more? Does that make sense?
It makes sense, but I'm wondering, how would you get that last or to apply to the first statement? How could you get it to apply to all the statements before it?
So that's what it's doing. So basically, this condition must be true. This condition must be true. And this condition must be true. Because we have this and this and this overall condition must also evaluate to true. But because we put this or here, it as long as one of these evaluate to true, the overall expression evaluates to true. So the way this is going to go is the actual database is going to roll through here, and it's going to say, okay, for film ID 26, is release year equal to 2006? Yes. Is rental rate equal to 99 cents? Yes. And so at this point it's saying and, so this, we know this must be true. Is the rating PG or is the rating G? Yes. Now let's go to the next one. So at that point, all three conditions, and because this is in parentheses, this acts as a single condition, meaning that one of them must be true because it's either this or this. Now, if we were to run this, the next one, so it's going to look at film ID 27. Is release year equal to 2006? Yes. Is rental rate equal to 99 cents? Yes. Is rating either PG or G? No. So at this point, this one's actually going to get thrown out. So we can actually run this, and let's look at, let's order it by film ID so we can actually see our original one. Order by film ID. So if we were looking at our, and what did I do wrong here? I need to buy. There we go. So we were looking at film ID. Now I can't remember which one it was. But anyways, now it would get thrown out. It's not included in the result set because now we only have rated PG and G movies. So all of these are being added. Basically, it's the same thing as if we were adding filters. So like I think about it as like, oh, filter it for this and filter it for this and filter it for this. And in this case, because it's in parentheses, it basically applies to all of them. The only time though, so when you're doing ands, it's pretty simple. So that's why really whenever I have an or, if I ever have an or statement in my where clause, I always use parentheses because that way it logically makes sense to me, if that makes sense. Does that make sense?
So you're saying that the or only applies to the preceding statement, the only one preceding statement.
Yes. Yep. So for example, like if I were to not have, let me do this. Let me take out the parentheses. because without the parentheses, this means something completely different. So in this case, because I don't have parentheses, what's going to happen is it's going to say, is release year equal to 2006? Yes. Rental rate must be equal to 99 cents. Rating must be equal to PG. So these three are all going to kind of be one. And then we have this weird or. So actually in this case, what's actually happening without the parentheses, and let's just run this because we can take a look here. What this is doing is it's actually doing this. So now these three must be true or the rating is equal to G. And we can see that in our results set. So if we look here, we have this G rated movie, but the rental rate's $4.99. So in this case, it's either rated G. So we're going to include everything that's rated G, or we're going to include it if it's PG 99 cents and from the year 2006. So that's why it's super important to make sure that, like I said, if I ever use an or, I always use parentheses, because that way I know what the results are going to be, because without it, it doesn't necessarily care. I mean, it cares a little bit about order, but when it comes to or, it's basically draw a line, everything before it versus or this. So in this case, whenever I have an or statement, I always just like to make sure to wrap it in parentheses. Even if I don't need to, I always do, just so it's very clear. And that way, if I go to add something, it just makes sense. Does that help at all?
That helps me. Thank you.
Yep. Yeah, I know it's a little confusing. So that's why what I would say is play with it. That's honestly, that's like the best thing we can do is play with it, try it out, because that's kind of where you'll kind of get, which is what some of the exercises and such are for. And speaking of exercises, actually, let's go through this. So the not operator, basically we can antiquate any conditional by just saying not. So like if I want everybody whose last name is Smith, I could just write that. And then if I immediately say, oh, I want the inverse of that, I want everyone whose last name is not Smith, I can just throw not in front of it, which is really convenient. Cause like if you're like kind of like pulling pieces out, like, oh, I want to separate these two, I can just very quickly just add the not keyword and bam, I have two sets essentially. Equal conditions, inequality, these should all be pretty fairly normal, and apologies because I'm trying to run a little faster. And a lot of these are just kind of some basic math kind of stuff that we've all seen before. Between. So there's kind of two different ways we can do ranges. And let me actually open up this website. At one point I was surprised. I'm like, wow, there's like not a single place for conditionals. And I think now W3 schools might have it there. But somewhere here, I put a right here. So I think this is linked in the announcements. In fact, I know it is. Basically, I put together this table that has all the conditionals, is at least the ones that I kind of commonly use, and kind of like did examples and a description. So I think this helps a little bit. So, and then I also, said that you can antiquate it with the not keyword, but basically we can, the between clause is kind of like our range, and it only works with certain data types, obviously, because we can't say between, happy and sad, like stuff like that. But we can use it for any kind of like time or numerical data. So basically what we do is we just say, oh, where date added is between January 19th and December 19th, so on and so forth. And that is inclusive, by the way, if you're wondering. But we can also combine that with greater than or less than combinations. So like if we wanted to say, oh, I want all the films that were released between, let's use cost. So I want all the films where the rental rate is between 99 cents and $3. So where rental rate, now we can do it like this. So let's do this first. 99 cents and $3. Now here in our results set, you can see we have 99 cents and $2.99. Now and the $2.99 is just the price. So if there were a $3 one, it would be inclusive. And in fact, let's just change this to $2.99. So it's not confusing where those ranges are. There we go. So we can still see $2.99 there. We can still see 99 cents. Now, the other way to kind of go about writing this with the ranges is we can kind of do it manually, which honestly, most of the time I do because it gives me more fine-grained control in a way. So we say where rental rate is greater than or equal to 99 cents and rental rate is less than or equal to $2.99. Now, again, whenever I do ranges like this, I always like to basically whenever two kind of things go together, especially if they're like in this case, we're doing like a range. Like I said, I throw a set of parentheses around it because mentally that's the way my head works. I want this to be a single conditional, if that makes sense. I want the rental rate between 99 cents and $2.99. So I kind of treat it as one, just like this one is. But I kind of build it out manually. So these two return the same results that they do the same thing, just a little bit different way of going about it. So you can choose which one you want to use. But sometimes this one's nice because let's say we only want it where it's greater than 99 cents, but less than $2.99. Now we should only see 99 cent ones because that's our only price points. So there we go. That is that. Let's keep pushing along here. Let's talk about that. So there's also nice little ways to kind of do some list stuff. So like in this case where we had our ratings, right? So let's take another version of this. We have our ratings, and what we'll do is we can, instead of saying this or thing, is we can just say and rating in GPG. Basically, we create a list. And so as long as rating is one of these values, as long as it's in this list, then we can make it work. And there it is. Cool. Now, on that note, one of the things you'll notice with a list that we just have G and PG. Now, the cool thing about databases, and someone asked us in the teams, is what is a derived table? Which is a great question. A derived table is any table from our query. So you can see here that we have this table sitting in front of us from our query. And in databases, whether it's a list or a table, they're really the same thing. But the only difference is a list is only one column, a list of records. So for example, if I were to say select distinct rating from film, we get a list of all the ratings. So what I could do here, if I really wanted to, is I could say where rating is in. Now this is a really roundabout way of doing this, but we're gonna just do it for demonstration purposes. So you can see I'm selecting from film, which actually, if I were to take out this distinct clause, would have all the records. So now you can see we have a whole set of duplicates. But I just put distinct in there, so we only get one version of each. Oh, and I put that in the wrong place because it keeps jumping around on me. Distinct. There we go. So with distinct, it filters it down to only the unique set of records. So in this case, we have our list. So theoretically, what I could do here, and what's cool about subqueries is we can see exactly what it's pulling. And in this case, it's pulling a list of PG and G. So what we can do here is, instead of actually manually typing the list, if we wanted to, we could actually throw in this subquery. And it's a subquery because it's a query within a query. So basically, the way the database is going to handle this is it's going to actually run this one first, and then it's going to, well, technically every time it checks a record, it's going to run this and make sure the record's in there. So basically, just like we talked about, this query is returning a list. So when we run this, it basically checks to make sure that the film is either PG or G. All right. And that's where our little subquery is. And I think this is the exact example that they were talking about in the Teams chat. Where basically it's checking to see if the rating is in a rating that has PET in it. And this query really doesn't make any logical sense, but basically what it's doing is it's getting the rating from film where the movie looks like PET. So let's actually just copy this, and we can kind of see exactly it's doing what we just did here, but it's just going about it a little different way. So we can go like this. So this is going to give us all the ratings from movies where it's like PET. And you'll notice that there's duplicates in here. So the one thing I would say to whoever wrote this is it would probably be wise to put distinct in there, but it doesn't matter. It's just to make it a little bit more efficient. So this is, again, doing exactly what we were doing, where basically it's going to get all the movies where the rating is either P or PG. Does that make sense? Have I lost anybody? All right. Couple more here. Wildcard. So what we can do is we can search very specifically for like text, which is really handy. So for example, if I wanted to find a movie that had the word dinosaur in it, I could say, I want to select, all the film, what's in there, film title. Let's just select everything. Select everything from film where, well, let's just see what it's called first. Title, it's just title. So let's just select titles from film where the title is like, and the like keyword lets us know we're going to do kind of like a fuzzy search. And what I'm going to do is I'm just going to put parentheses, and as long as it has the text dino in it, it's going to return. So let's see what we get. And look, we get 3 movies. We get Academy Dinosaur, Center Dinosaur, and Dinosaur Secretary. Now, let's say that we know we're looking for something very specific. Like, let's say, we know it starts with the movie The, right? The. Let's see if any of our movies start with the, nope, none do. Okay, let's try A space. None of those either. Okay. I don't even know what kind of film movies there are in here. They're all fake, so that's probably why. Oh, and what? Oh, that's a description. So let's actually do description. Let's pull description in here, and let's do it where the description is like, and let's say that we know this movie is about a dog. So we're gonna throw in dog here, and there we go. There's lots of them actually. Cool. So then let's try another one. Let's say we know that it's trying to think of a good one here. Let's do it where title, because we can do specific like single character one. So let's do Oh, I don't even know. Let me see if there's anything in another table, actually. Let's see what one might have it. Let's try actor. No, let's try. Ooh, that might be a good one. Let's try state. Is there a state? No, there's country, city. City, country. Is there not a province? Maybe that's an address. District. Okay, but it's not the letter words. Okay, let's look for postal code, right? This will be good. So we want to find all the addresses where the postal code is like, and we can do something like this where we say 3520 underscore. And what this will let us do is find specific strings, postal code, like this, to where, hey, I don't care what the last digit of the postal code is because we're trying to target this larger area. So as long as the postal code begins with this kind of prefix, we don't care what the last digit is, but we don't want any more than that because we could do this as well, but that would say anything, whereas the underscore means I don't care, but it only can be one digit long. So I don't care what the last digit is, but it will be a character of this length essentially. So pretty neat. Then that's the like operator where you can kind of do fuzzy searches, so to speak. All right. And then nulls. So null handling is basically where we're looking for something that is empty. And believe it or not, empties in databases are largely handled different than other things. So for example, if we wanted to look for something that's between something, null is going to be excluded from that, and so on and so forth. Or less than, like if I said, oh, I want, where everything is less than a certain amount, if it's null, it's going to be excluded. So what we need to do is we need to handle nulls in their own. So let's look and see if we can find something. Let's look at address here, actually. Let's say select everything from address. And you'll notice that many of these have address to that is null. So let's just say where address to is equal to null. Now this isn't going to work with the equal sign, which takes a little bit of getting used to. Basically, you have to say is null. So when we're checking for select everything from address, I guess it helps if I spell it, where address to is null. So here's our addresses where address to is null. Now let's see if we can find ones where address to is not null, basically is not empty. Oh, and if we look here, see, this is interesting. If we look here, you can see that this isn't null, but it still doesn't have any data. So let's go back and look at the ones that are null. So is null. You'll notice here that in the output, it actually has this little null box. And like I said, there is a difference between an empty string and a null, which can be very, very confusing. So you have to actually, like if we're looking for things that are empty, we have to do both. So we can say where address to is null, or, and again, we're going to put this in parentheses, address to does not equal an empty string. Oh, and let's see, or is does equal, sorry. So it's either null or it's an empty string. Now we should get the whole lot of them. Cool. Now, what's cool is we can, like I said, that not keyword. So these are all the ones where address to is empty. And instead of having to change this and this, what I can do is I can just say not. And it looks like we don't have any. but if we did, it would be there. In fact, let's just fix one real quick so we can test it. 47 MySQL Drive, address 1. So I'm just going to real quickly say update address set address 2 equal to apartment or number 345, where address ID is equal to 1. There we go. So now we do this, you'll notice that we don't get that there anymore. And then if we add not, we'll get the one that actually has address 2 data. Cool. Any questions on filtering data before we jump to the final project? All right. Final project. So in this course, you have 2 options for your final. One is the final exam, and the other is to do a project. They're both worth the same number of points. You don't have to do both, but only the highest score from one or the other will be kept. So yes, you can do both if you choose to do so, but only the highest score will be kept from either. Now, that being said, just so you know, I'm going to be upfront with the final project. Because you have a long time to work on it and get my feedback, I have yet to have a student who like actually finished their project that has not gotten 100%. So if you want 100%, you're willing to, put in that time throughout the term, I would highly recommend the final project. Many of the students said that they learned more from the final project than they did almost the rest of the class. We'll also spend much of our weekly meetings here talking about tips and tricks and stuff for the final project, because the final project really is like the perfect kind of learning experience for this course. So I would highly recommend the final project if you're completely slammed. And really, I think, I don't think it takes a lot of time as long as you don't procrastinate till the end. But the final exam is an option too, if you'd rather just not worry about anything until the very end and just kind of get it all done with one kind of painful go. So anyways, let's talk about the final project. So there are a couple of deliverables, and we're going to talk about each one. So the final project requires you to design and build the blueprint for a database, an ERD, which we did in week 2. And I actually have one here because I've actually done one of these samples. So basically I made a cookbook. And so basically kind of like what we talked about last week in the video, it's really fairly easy to kind of go through and start building these. Now this one needs to be much more cleaner, which we'll talk about next week in our weekly meeting. We're going to talk more about this, but basically you're going to start going through the design process in your head about what would I build and how would I go about making sure that it will act and behave and store the data that I want to. So just to real quick walk you through mine is a family cookbook. So basically over here at the very top left, we have a system user, and this is anyone who has an account with our system. So I kind of built mine to be like a database. Sorry, not a database, a website where you can go and I thought it would be like family search where, people could pass down family cookbooks essentially. So anyways, you have a system user, and every user can basically create a family. So if I were to create a family, or let's say my mom, she made her account and she created a family. So here we have, the Crook family, and she can add us as members. So she says, hey, there's this really great website where we can put all of our recipes together. And we say, great, so she sends us a link. I sign up. She invites me to be part of the family, and bam, I'm now part of the family. So there's that kind of structure where basically we have family members. You can kind of see how that ties together. A single person might own a family. That's this owner user ID that links back to a system user. But then over here, a family has a list of family members. So that's this family member table. So because a user can be part of multiple families, you can imagine if I also wanted to be on my in-laws recipes, so I can get all their great Dutch oven recipes. So a user can be a part of multiple families. So the way you design your database is important, because if I did this a different way, that might not be the case, that a user could be part of, multiple families. So that's why this little thing exists here, where me as a user, I can have multiple entries in family member. So for example, let's say my user ID is 2. I might have a 2-1 and a 2-2, and user ID 2 is me, family ID 1 is the Crook family, user ID 2 is me, family ID 2 is my in-laws, so on and so forth. So that means that way we can kind of track, oh, this person's in multiple families. And then a family can have multiple cookbooks. A cookbook can have multiple recipes. A recipe is owned by a user. A cookbook is collectively owned by the family. You'll notice that there's no tie from cookbook to a user. So basically, cookbooks are a collection of recipes that exist within a family and are owned by the family. But a recipe has an author, and that author connects to a user. All right, and then every recipe has a step, step 1, do this. And each step has ingredients. It can have multiple ingredients, which is pretty cool. So, because the way I kind of like to cook is it's like, okay, step 1, like for example, if I'm doing steak, we need to first, let's make the marinade, right? That we need to let it soak in. So step 1, let's mix the marinade. So in those ingredients, just if you need them, we need, Worcestershire sauce, garlic, salt, pepper, oil, olive oil, right? Those 5 things. So those would all be ingredients in this step, and then each step would have its own. And what's cool is when we display the recipe, we can just say, hey, get all the recipes for all the steps, and there's our total shopping list for the whole recipe. So it kind of kills 2 birds with 1 stone. It makes it really detailed, but also we can get at all of it later. And every ingredient is shared. So that way you don't have to type milk every time. You can kind of select it from a drop down. And then every ingredient has an ingredient type. So, if I'm looking for an ingredient when I'm making this recipe, I can say, oh, they need olive oil. So, that's in the general or sauces. And then, oh, there's olive oil. Or, oh, if I'm looking for garlic salt, I go to seasonings, garlic salt. So seasonings would be the ingredient type. And then a measuring unit is basically just a common way. How much of this do we need? Is it a cup? Is it a teaspoon? Is it a millimeter? Because we want to make it uniform. So these measuring units will be commonly defined across the whole database. But anyways, that's kind of an explanation of mine, but that's what we'll go into more detail in next week when we really start to dive in to how to start this process. What I would do for now, because I think it's important to come. So if you're coming next week, next Tuesday to this meeting, it would be really helpful if you came with an idea, because if someone has an idea and you're willing to volunteer, I will help kind of kick the ground running so we have something to build together versus just another one of my ideas. So what I would do is, if I were you, we don't need to get super detailed, but just think about all the individual things you'd like to have. So like if I'm doing a database that tracks, I don't know, like we did one last week with courses. If I'm doing something like that, I have people, I have a course, I have a section, I have an assignment, I have a score, all those kinds of things. Think about those and just kind of build bubbles. So just draw a bubble, give it a name, and draw a line that connects it to something. And if you want to show like, oh, this has many of these, if a course can have many sections, do your little crow's foot, which is this little 3-pronged thing that looks like a little chicken foot. Do that. So that way you kind of know like, oh, this is the hierarchy. And I like to think about it as a hierarchy that gets really messy, because like a system user owns a family, and a system user owns, is a owner of membership in a family, and a system user owns a recipe. So I like those crow's feet because it tells me, oh, this person or this item can have many of these, and it's the owner of those things, so to speak. So it's kind of a hierarchy. And you can keep it that simple for right now, because then we'll kind of build off of it next week. So that's one deliverable, the ERD. And what's cool is it will generate, once you build the ERD, it'll actually generate all the database code for you. So you don't have to do much besides build this, build the ERD, and then you can actually go up here to database, forward engineer, hit next, type in your password, hit OK, hit next. And what's cool is it actually will build the database for you. If I were to hit next right now, it would actually build all this for me. And so then all my tables are there. So that's the next deliverables. It's just got to be built, which is not really a deliverable as much as a step. And I think there's a better spot here with deliverables. Yeah, here we go. So ERD, this has a minimum of 12 tables. I'll take it with 10. You need to have some. So that's the ERD. The next thing we need to do, which really counts as like the database itself too. The next thing we need to do is create test cases. And test cases are basically like sample code. And this is where I'm actually going to start showing you some of mine. And that sample code does these things. So all of those include these things. So an index that maps a user interface to some SQL that happens. And then we have a user. So these two are kind of one and the same. So let's actually go over mine. So this is for my recipe. And I don't know if I can zoom out on this. Oh, there we go. So basically all you have to do is kind of map out your wireframe. And there's this great website called draw.moyu.io. It's super easy. I think I did this in probably a half hour. Pretty easy. But you'll notice over here in the red on different things, I have like cookbook.r.2 and cookbook.c.1. And what these are referencing is actually a line of a query somewhere or a statement, because whenever I do something on the website, something's going to happen with the database on the other side. So for example, if I'm creating a recipe, I need to choose what cookbook do I want this recipe to go into. So when I click this little drop down menu, this cookbook.r.2 is going to read from my database. So let me open how do I open this? Open file somewhere. I believe it's right. Let's just go to it in my file browser here. Samples, and here we go. So here is my CRUD. Open it up right here on Workbench. So now if we look at this, if I were to go look at cookbook.r.2, let's go back here. Cookbook.r.2. So if I look at this, it's going to get the cookbook ID and the cookbook description and display here. So that way I can select which cookbook I want to put it in. Then if I were to look at the save button, recipe.c.1, I can go back to my CRUD statements and let's look at a recipe. recipe.c.1, and you can see here that it's inserting a recipe. So, and this is just, you can kind of put fake data, because you'll notice my UI doesn't actually have any data in it, which we want. But here we can just kind of put in some fake data. So looking at this, you can see where I'm having the user Samwise, short for Samwise Gamgee. If you're not familiar with Lord of the Rings, it's his cookbook. So it's the Gamgee House cookbook. The description of the cookbook is everything potatoes. And in this case, I'm building a recipe for potato stew. It takes 30 minutes of estimated prep time. And the description is boil them, mash them, stick them in a stew. So basically some fake data. But what's cool about this, the whole idea is that you know what's happening. So like, let's say that I'm the person who's actually going to be programming this. So let's say that you put the database together like you are. But let's say you then kind of say, okay, web developer and backend developer, here's how this is going to work, right? And they have enough to go on here because they can look at this and say, oh, the save is going to execute this SQL. Cool. Then all they have to do is replace the fake data with the data that's kind of part of the system. So it's not like you actually have to build a whole system. You just have to build the database and kind of provide enough context to give to someone else to build it. So basically you're doing all the database work and then kind of showing them kind of how you expect it to work. So this is where I this is where I edit a recipe and do my steps. And you can see here that we have similar thing. We have a recipe.r.2, and this will read all the information from my recipe. So again, let's go take a look. And you can see here, I'm just selecting everything from recipe where the name is potato stew. So just kind of finding a specific recipe, and then I can kind of display the name, the description, and the cookbook. Then I have an update where I say recipe.u.1, and that's where if I were to change the name of this recipe, I could click update and it changes the name. And then steps, and I haven't completely finished my UI. So normally I would have a button to add step. And then I have this delete button where I can delete steps. And, like I said, I haven't quite finished mine because I was just kind of doing it for demonstration purposes. But you can kind of see, basically, you just need to UI map a basic flow. So for mine, it was, this is how I create a recipe. This is how I update or view a recipe. This is how I would edit a step. And this is how I view all the recipes in a cookbook. So, it doesn't have to be all encompassing, just enough to kind of get the general idea across. All right. And so that is our index map and our UIs and our test cases. So pretty simple, nothing too crazy. Yeah, not too bad. And then finally, you create a PowerPoint presentation that just walks you through all of this. So that way, kind of what I've done here for you, I say, this is what my project does. Here's my ERD. And then you go into oh, here's my screens. This is what they do. This is how it works for the user. And then at the end, you can do a couple slides of oh, this is what I would have done differently. These are where my mistakes are. Because again, it doesn't have to be 100% perfect, especially because you might get to the end and you'll be like, oh, I should have done this. It's okay. You don't have to go back and redo everything. You can just leave it, just highlight it, note it, and then in the PowerPoint kind of say, oh, and this is what something I would have done differently is. And we'll go over these more along. Like I said, I have a timeline. So basically what general timeline looks like is from weeks 3 to about week 6, 7, we're working on ERDs. So from week 3 to 7, we're kind of working on ERDs, kind of getting our models kind of figured out. So you have a few weeks just to kind of build your database. So plenty of time. You have lots of time to think about it, lots of time to fiddle with it. If you spend even just a few hours every week, you should have plenty of time. And then after that, we'll spend a few weeks working on our test cases. So basically from week 7 to 11, we're going to work on strictly just doing our CRUD cases and that kind of thing. So this is where we have like our create, read, update, delete with all of our stuff. I don't think I showed you that one. So let me hurry and say open SQL script, documents, samples. Here's my CRUD. So basically for every table, you have a way to insert a record, read the records, update the record, and delete a record. So basically just for every table, create, read, update, delete, which is just insert, select, update, delete. So not too crazy. And again, we'll go over this in more detail. So if you don't get it now, don't worry about it. Cause like I said, I kind of have like this timeline that works really well. So as we hit those time marks, we're going to go over this in great detail. So that'll be from week 7 to 11, maybe 6 to 11, depending on how things are looking. Cause these are kind of what take the most time. So we'll probably do this from like 6 to 11. Just to kind of give you some more time. And then the last week or two, so basically from week 11 to 13, you can just work on your PowerPoint, cleaning everything up, and getting it submitted. And what I usually recommend is that you submit it early. So like come like week 11, I'll say, hey, you know what, let's start submitting these. Once you get them kind of where you feel like it's ready, go ahead, submit it. You'll either get your full score then, or I'll say, hey, you know, this needs a little bit more work. I'll send it back. You can fix it, resubmit it, and done. And most of the time, like I said, I don't expect them to be 100% perfect. But I do expect all the deliverables to be complete. So if the deliverables aren't complete, I'll send it back with some feedback. You can just kind of get it fixed up, add it up, and then get it there. All right, that was a lot to go over. And like I said, we'll be taking this starting next week. We're going to start taking this a lot more kind of detailed. But for now, start thinking about your model and what project you might work on. Does anyone have any questions about the final options? All right. Well, if there's nothing else, we will end about I'll give you back 6 minutes of your time. But anyways, thanks for being here. Good luck this week. If you have any questions, feel free to reach out as always. But yeah, good luck this week.
Thank you.
Yep. Thank you.